There comes a time in the life of every human being where it tears down a microwave. So, without further ado, let's do it. And I will be most detailed about it, as always. Yeah, by the way, I'm using a wide angle lens and I hope I have a fitting bit for these, well, not really security screws. Oh, there are security screws. Oh, yeah. Security screws that budge using a non-security bit. So, yeah, really secure. I'll throw these away. Yeah, and they are security screws. So they put in security screws so you won't screw up. So no fun at all, huh? Yeah, there's a story, and I don't know where to begin. These are not security screws, just Phillips. Yeah. Okay. I have to jump a little bit in time for that story. So lately I had the idea that it would be nice if I could do some welding, specifically spot welding. No big things, just thin sheets of metal, and no, not for batteries. I have something else in mind. And well, what do you need for that? You need a micro oven transformer that you rewind from a high voltage transformer into a high current transformer. And so I did what everybody does. I went on eBay, but everything there, at least here in Germany, delivered, was actually quite expensive. And I think there was an auction with a nice one that was not that expensive, but of course by the end of the auction, yeah, too much money involved. I mean, for old rusty piece, again, security screw here, opened with a non-security screwdriver. That last bang was not inside here, I hope. And by the way, this thing has yeah, 700 watts. Oh, and it's drawing 1150 watts. Okay, that's important if you want to know what the transformer is capable of, because a lot of the heat is actually, or a lot of the electric energy is wasted in the magnetron. Okay, it's almost giving away, not quite. I'm not sure. And we are in. Okay, let's have a look at the more interesting side here. that is the first time you're in a magnetron. Sorry, just gave it away. In a microwave, this is a magnetron that generates actually the microwaves, and I should be able to remove these connectors quite easily, or not. Give me a sec. It's all spade connectors or quick connects, so come on. Yeah, they're quick to connect, but sometimes very hard to remove again, which is quite okay. That's the intention. We have that nice big microwave oven transformer here, which we'll have a look in detail later. We have here which, oh, sorry, you're almost out of frame. We have here at the top something that looks like an antenna, but they just took a solid core wire to fix the cables. Or maybe it is some kind of secret antenna. I mean, maybe the whole thing is a bug and sends via microwave frequency back to the Chinese Secret Service. Who knows? Antenna. There. At the very top. Okay. So I have no idea why that would be there. I give you another perspective in a second. Yeah. Then on top of the magnetron we have a temperature fuse or switch, probably a switch, also with spade connectors which disconnect a little bit more easily, maybe, or maybe not. And I fear I need another Phillips. Do I? No, it's working. So I think I mentioned that a lot of the electric energy is dissipated as heat in these magnetrons. So that's the stuff that actually gets hot. The microwaves that actually enter the oven or the chamber, they are mostly absorbed by the stuff. And this is, can we read that? 160C. It's a temperature switch. 160 degrees Celsius. So so emergency switch off, sorry, out of focus, appears only at 160C. And then we have here something. I know what that is. Sorry. Have to go a little bit up here. Spade connects. Rocking your world, ain't I? Yeah, some of these quick connects or spade connects, they have kind of a snap in that goes here. I will show you in a second, which makes it kind of hard to disassemble. If I... Oh, come on. Okay. This will be a destructive disassembly. Wonderful. And the whole thing is held in by another screw, and behind it we have the light bulb. Wow, is that thing that old that they put a light bulb in here? Huh. And now we are ready to get the magnetron out. Only 4 screws, 2 at the top. And 2 at the bottom. And there you have your magnetron, which is called magnetron because there are magnets in there, and you see a whole lot of cooling fins. I think I mentioned that these thingies here create a lot of heat. They're quite efficient, but I mean not 100%. I would have to look it up. This is the business end where the microwaves come out. Here is some brass fabric or something to make a nice microwave tight seal around this part here where it goes into the oven chamber. Can't have any microwaves leaking out here with the electronics up there. That would be not so good. So there's our, well, not control board, say that's input whatever board, and yes, there's not much on there. Okay, so let's get that free. Yeah, I don't know where the story. Yeah, I wanted a high current transformer, or rewind a microwave oven high current transformer, and couldn't get one for a reasonable price at eBay. For a spot, to do some spot welding on a thin metal sheet, and then I walked here through the city, and somebody threw out an old microwave, and I thought, that is a sign. That must be a sign. And well, here we are. So there's a lot of connectors going to the front. Yeah, and there you can see the springing mechanism, which in theory you should be able to push. Sorry, out of frame. Which in theory you should be able to push and then to pull. Yeah, works like a charm. Where was I in the story? Yeah, so somebody had thrown out this microwave here, and I thought, oops, that is a sign, and took it with me home, and here we are. Soon got it out microwave, and me soon having a microwave oven transformer in my hands to rewind. And of course this will be another video with will be too long and include a little bit of transformer theory. So, yeah, basically what we have here, that's it's not much. It's a lot of 5-watt resistors here. Maybe I do a little bit reverse engineering why they are here. I have no idea. They are partly in parallel, these two, so 2.5 ohm, 10 watts. Or maybe they are more than 10 watts, I have no idea. Yeah, maybe I have a look at it. But yeah, lots of resistors. There's even some diode, so they make 50 volts. Can you read that? I don't see a capacitive drop. Where do they get 50 volts? Oh, maybe interesting to look at that thing. A little relay, which is rated for 10 amps at our mains voltage. 10 amps at 277 AC. Huh. And 7 amps at 250 DC. That's not a bad relay, not at all. Yeah, a fuse and an X2 capacitor with 0.33 microfarad. But I don't think that is used as a capacitive dropper to create some DC. I think this is used in conjunction with this common mode choke at the entrance. But there's also a discharge resistor, probably. This is 47K or something like that. Huh. Yeah. Some MOFs or NTCs. Huh. Okay. In detail later. Okay, not much here. A very nice power cable. If you're in the market for something like that, but yeah, for experimental purposes, not too bad. Yeah, I mean, I finished the story about that one. And this is all snapped in. There's a screw. Sorry. There's a screw. Yeah, there are enough videos about these kind of motors, but I have to look up the name again. Let's I'll look it up. But they never die. They cannot die because, okay, they can die. I mean, obviously the bearings can seize up or something, but otherwise they are most quiet because there are no brushes. And yeah, this is cooling the now removed Magnetron, which yeah, I mean 1150 watts go in, 700 watts of microwave go here in, so somewhere 450 watts get lost. A part of it in the transformer, but a transformer that size has easily 90% efficiency, maybe more. I don't know. So we are then down from 1150 watts, 90% of that, let's say 1000 watts electric power going to the magnetron, and only 700 entering in form of microwave the oven. That means the magnetron is dissipating 300 watts. You need to cool that. And what have we here? Yeah, a diode. That's a high voltage diode because a magnetron runs on DC. Is that a diode or is that a fuse? I think they have a 5 kilovolt fuse in here. Have you ever seen a 5 kilovolt fuse? Yeah, it's a fuse. Come on. Must be kidding me. How cool is that? How cool is that? A 5 kilovolt fuse. Yeah. That's definitely something I need in my life. So these cables are also rated 5 kilovolts, I guess. I mean, that's not bad. So 5 kilovolts, 0.65 amps. And this, of course, is again... No, it's coming off. So the high voltage circuitry is fused. And this comes then from the transformer, and maybe I look up how these things are connected. Okay, there's a diode going to the chassis and a high voltage diode, of course. And if you look here, one side of the high voltage winding is going to the transformer's body, so also to the chassis. So yeah. And if I'm not 100% sure, I will look it up later. The output of the transformer is basically through the diode and through the the diode and that capacitor. That's again a high voltage capacitor for 2100 volt AC. So easily 3000 volts DC. 0.95 microfarads. Yeah. It's too late for any security concerns, but you see it has a built-in discharge resistor. That's nice of them. They saved me. So almost a microfarad at AC, so you can load that up at 3000 DC. I mean, that's a nice one. And you have here the high voltage diode. And maybe I'll look up the circuit and show it later on, but let's get that stuff here first out of the way. Then we have the transformer, which is connected again with some spade connectors. They only know spade connectors, obviously. Now we have to get the transformer out, which is, I mean, this is a big thing, screwed down with screws. What else? And it's 1, 2, only 3 of them. And he slid in here on the cutouts. So I told the story about that transformer and how finding this thing was a sign. And yeah, that's basically the story of my, well, not my life, but my project life. I mean, if you remember, I started out doing some calculations for statics calculations for a CNC machine, a small CNC machine. And then when I wanted to do something for real, you know, with stepper motors, my 35-year-old power supply died on me. And I started, yeah, after gutting it out completely, to repair it. Or to rebuild it, not repair it, rebuild it. I mean, the innards were a nightmare. I have no idea how this is supposed to come out. I mean, I can slide the transformer back a little bit. Okay, here it is. Ooh. Okay. That's not fat from the kitchen. That's epoxy or something holding the whole thing together. And it looks in reasonably good shape. Only here the epoxy has went off. Here you can go over with the file if you want. Re-epoxy that. Otherwise only very little rust on it. And of course, that's why everybody wants these things. These massive primary windings. That's your mains AC, so hereabouts 230 volt AC input winding. That's massive. I mean, I said this thing is gulping 1.15 kilowatts. Yeah, and you have the high voltage winding here, and then you have that additional okay. I'm a little bit okay. That's a high voltage winding, and here is the high voltage connector, and that winding here, these thingies, are actually for heating. Because a magnetron, I think at least so, you have two connections here, okay, but they are not both high voltage. I mean, the chassis is one of your high voltage rails. The other high voltage rail, yeah, high voltage wise, these should be on the same, absolutely the same potential. There's only, I think, a few volts here for, yeah, some heating, you know, like in a tube, in a triode also. Yeah, we'll take it apart later. Okay, not much left now of interest. Is there? Okay, so I started repairing my old power supply. My 30... Oh, no, I'm lying. Yeah, maybe it was 30 years old. No, 30, let's say 32, 33 years. And while building it up again, my other power supply, which was only my first one I ever built, yeah, it died too. So I gave that one a new share of life successfully. That project is actually finished. And then I got somehow sidetracked and started making a UV exposure unit because I thought it will be really cool if I could do some circuit boards at home, because I got really tired of these soldering stuff on perf boards. It was a sign again. I teared down an old scanner and a really small one, thin one, and thought, yeah, let's make a UV exposure unit out of it. But that didn't turn out so well, or at least I recognized. Oh, the bell. Dinner's ready. Not very convincing. I teared down that small scanner. I think it was a Canon one, and there will be links for everything down below. And I found some cheap UV LEDs, 100 pieces on Amazon. And as soon as I got these UV LEDs and I looked at them, there's no way I could fit that all into the tiny scanner case. So I bought an old defect scanner, bigger scanner, really old scanner from eBay, and started to build my UV exposure unit in it. And the second board I did for that UV exposure unit, the power board I did on perf board, but the display and keypad board, it has to be really tiny. So I thought I etched that, really printed circuit board, and so I started to get back in making circuit boards again. And then I realized that nowadays you need some heating, at least some controlled temperature for these. I think in the olden days we always used ferrochloride. I don't know if I got the English name right. Anyway, in the olden days, nowadays you should use, or they say you should use something not so harmful. I think sodium persulfate, and that needs to be at a certain temperature. Otherwise, you wait for 1.5 hours until your board is etched. So now next sidetrack project will be a little water bath where I can put the container with the etchant in and heat it up to the what it is, 45 degrees Celsius or something you need for fast etching. There's another cable. Where's this going? Oh, we will find out. Anyway, and in conjunction to that heater, I need to spot weld a little. It would be, let's say it would be ideal if I could spot weld a little. And so, the need for a big microwave oven transformer arose. To rewind and build a spot welder like everybody else has, obviously, but me, at least if you trust YouTube. Lots and lots of micro switches. just a V-tap to the bottom, and then we have here a whole lot of switches. I mean, one switch is obviously checking if the door is open, so you cannot switch that on, the whole thing, while the door is open. And these are nice switches which should be getting out quite easy. Another switch would be, I guess, the general on-off switch. And it's like a puzzle. It's like a puzzle. Every switch is installed a little bit different, and you have to depress the right bars to get the switches out. How cool is that? And people pay money for puzzles. Okay, I guess that microwave once costed also a lot of money. And I have no idea why there are 3 switches in. So one checks for the door be closed. That would be one of these holes here. No, wait, actually, let me reinsert this. That way. Here was a micro switch, and here was a micro switch. Okay, top and bottom. And the door has 2 latches. So they actually use a full 2 micro switches, redundancy, to check if the door is really closed before they energize that magnetron. And then we are left with this stuff here, which is basically a power setting. Which just goes through some cogwheels up into this module, and this is the timer. This is most interesting. I guess we can simply heave off these and then we have here this electromechanical marvel. This thing is also of Chinese origin. Contact capacity 15 amps at 250 volts AC. There are 2 contacts, and also the bell should be mechanically actuated. Yeah, here's a little clutch. Now I understand why there are 2 contacts. Yeah, one here, which is regularly broken or not. And that's the on-off switch. So if you turn the intensity dial, that was this part here, that only adjusted here internally some of these cogwheels. So let's say the interrupter opens more often, and so reducing the total power or the total amount of microwaves induced into the oven chamber. And the second cogwheel, this is coupled to the bell. This is really the on-off switch. So if you wind up the timer dial, this switch is closed, and depending on the position of the intensity dial, that interrupter is opened not at all or more often. And it's completely, the whole regulation, power regulation and timing is all completely mechanical. There is another of this never dying motors. Very, very tiny one. Time to clean up just a little bit before we follow this cable to the conclusion of the teardown. To access the motor, which is hidden here, which turns the table. There we have a synchronous motor, obviously geared because this is off center, and it turns here in 50 Hertz land 5 times a minute. Time to get to the interesting stuff. The Magnetron. This brass fabric is so nice. Here I guess we will have to crack open this thing. And I fear I will have to do that off camera. Well, I would love to say there's not much here in the can, but yeah, these are basically 1, 2, 3, 4 coils. 2 air coils and plus 1 with a ferrite core, and there to make sure that no microwaves escape through the cables out. There's 1 magnet, and this is, I mean, it's a nice big magnet, but it's not a neodymium magnet. And it would be so nice to see the geometry inside it. One word of advice: if you ever want to use these magnets, they are very brittle. I mean, I just snapped the 2 together and they broke. And I managed to liberate the core of the Magnetron. Yeah, this was where our heating current goes to whatever lies behind here. And this was the business end. Yeah, it would be nice to get it open. The reason this is copper, probably not for, maybe for electrical reasons, but also to dissipate the heat. I think at the beginning we calculated this thing dissipates 300 watts. So this is basically 3 soldering irons at once at full power. So there you have it, the Magnetron, or what's left of it. Yeah, where to start? You remember the third winding on the transformer, not the high voltage winding, but that also very thick, only a few turns winding. It was connected across these 2 contacts here. And this went up, and these were isolated from each other. Okay, just by an air gap, and yeah, there was another part that belonged to it. It was here, and you can actually see a tiny bit of the filament here a tiny bit of the filament that then spiraled down from, and this was just you know, AC heating, a few volts, spiraled down here from one pole of the AC, low voltage AC source to the other pole, and probably glowed red hot inside the thing. The whole assembly, I broke it off here, was sticking in here. So with that on top. And okay, now you would need really a 3D camera. If you look at Wikipedia photos or drawings about magnetrons, you know this structure here. That is, I mean, you have the outer cylinder, which is, of course, massive copper, and then you have these fins going in. But these fins are not going all the way through the body. They're just in the middle of the cylinder. Okay. And of course, they are bent from the sawing. And the top and the bottom of the cylinder, there are two smaller copper cylinders. I think they only have a mechanical purpose. Yeah, to keep them upright, maybe. Yeah, so this was the input end with the heating filament, and this is the output end. And yeah, we have again these fins going in, and they go not completely to the bottom. They're just really in the center, center third, center fourth of the whole cylinder. And yeah, again, these probably only support structure. And yeah, this is closed, completely closed. That was the business end. There was a cup on it for no special reason, I guess. Yeah, maybe directing the microwaves, because basically that section here, which has been yeah, quenched down, probably they evacuated the whole thing. There's a vacuum inside, otherwise you know, the glowing filament and electrons flying around wouldn't work really. They probably evacuated, sucked the air out through this end, and then closed it up. And this is also your microwave antenna where the microwave come. But how do they end up here? And this, the secret here is, it's really like an antenna. So the microwave frequency is generated here. Yeah, look it up, maybe a few words later, is generated here in these fins through the energy which is introduced through the electrons emitted by that thing in the center. And see that copper wire? That is the antenna tab. It's connected here, and it's going down there to, yeah, our sending microwave antenna. That's all. As I said, it's complicated. Look it up. Not part of a teardown video, but what you basically have is a lot of inductivities. Yeah, this is part of a coil. Each segment is forms part of a coil. And capacities. These plates form each a capacitor. Yeah, with plates connected here. And the whole thing has, of course, an LC element, capacitor inductor element has a certain, and many of them has a certain resonance frequency. And that resonance frequency happens to be the microwave frequency the oven is working on. And the whole thing is again powered by the electrons, which come from the now high voltage, talking about high voltage, negatively charged glowing filament here to the high voltage positive body. And the poor electrons cannot fly directly to the fins because, the magnets I destroyed, because of the magnet field. As soon as they try to fly perpendicular to the magnetic field, they are, it's called Lorentz force, look it up, they are forced into spirals and accelerated until they finally hit somewhere. And where they hit depends on if, let's say, this capacitor plate is just positively charged for some reason. And here we'll stop the explanation, and the neighborings are, of course, then negatively charged. Then the electron will somehow hit here, the positive ends hit on the electrons will hit on the positives and charge them up more until something happens and the whole process flips over, and then it's, as I said, it's complicated, but a little bit more complicated than the Wikipedia picture, as I said. And I almost forgot, here you have the rest of the filaments. So it's really thick, and I think it's only red glowing, not white glowing, red glowing, and that's enough to emit in that high voltage field the electrons. How does all the stuff with the high voltage winding? Don't forget, one thing is going to ground. One side is going to ground of that high voltage winding. The high voltage capacitor and the high voltage diode work. That's actually quite simple. So this is our magnetron. And let's assume for the moment we are in one half wave. Here's the primary coil. Let's assume for a moment that we are mains AC in, I call it the positive half of the sine wave, and we have plus here and negative is here. Then of course current is flowing through the capacitor and is shorted by the diode back to this end. So nothing really comes to the magnetron, but the capacitor is charged up to plus minus. When now the negative half wave comes, the negative half wave of mains AC comes, this side is positive and this side is negative. And now, of course, the diode is no longer conducting, but now the voltage in the capacitor, minus plus adds up to the voltage on our transformer coil. And so we get a current flow through basically positive end here, through the magnetron and our capacitor discharges here, this direction. And what that does, obviously, we charged the capacitor up with one sine wave, half of the sine wave, and we discharge it in series with the second half of the sine wave. So basically, yeah, let's say this is 0 volts, and this is our sine wave. Then our capacitor is charged to this voltage. It doesn't discharge without load, okay? And then comes our second half wave, which in the output, yeah, you have to mirror it, adds up. So basically, in the end, you get something, a voltage looking like that, without the load. With load, of course, the capacitor discharges a little bit, so it gives in between, which is basically two times output voltage from the secondary of the transformer. So this basically is kind of a voltage doubler. That's all to it. That leaves us with the circuit board, which is surprisingly complex. I will try to reverse engineer it. That thing actually holds some surprises. It's basically two circuits on one board. It starts out with a bog standard mains AC filter. So you have live in, you have neutral in, you have an 8 amps fuse, you have the first, the big X2 capacitor between live and neutral, common mode choke, and two more smaller capacitors, these ones connecting live and neutral out to earth. So this basically prevents any bad things from the microwave oven getting out into your mains AC net. The rest of the circuit is interesting. You have basically from the control panel, from the front, come in two lines, a switch out and a P out. Let's forget about this stuff here and just switch out. So if you switch on the whole thing, power comes, goes through two 47 ohm 5 watt resistors, these thingies, into the transformer. And the second input goes through two 3.3K 5 watt resistors through a 1N something diode, a 400 volt diode, I would guess. It's rectified into a capacitor, and this makes me think either this is live, will be connected to live, and this will be connected to neutral, otherwise that whole rectifying circuit won't work. So it's charging up the capacitor. There's a Zener diode limiting the voltage of the capacitor. So if you put that from open to neutral, assuming this is live, the whole thing charges up, closes the coil, and either, I haven't looked that up, but it doesn't matter, opens or closes the relay contact. So all what that is putting 23.5 ohms in series with the transformer or not. And that is basically how they modulate the output power of the microwave. So yeah, there you have it. That was the most detailed microwave teardown ever. Bye.